PID systems. Okay, so these are all used to set the speed of fan. So all right, now we have different. You could choose different boards. Like say, let's say if you're using these are all different functions which are available, and drivers for driving your stepper motors. Also, I will. What I'll do is I'll also leave a link today for giving you, if you're interested in knowing about configuring the Marlin firmware in detail. It actually requires a lot of time. So for that purpose, I think it's better to start from the basics. So what I'll do is I'll actually leave certain resources for you people to follow up, and uh, it's always better to start with a basic Arduino and try out several example projects. And with that understanding, in a month or two, you could you will be getting familiarized with this particular programming language as well. So you could easily configure your machine, and then you could start 3D printing, building your 3D printer. And so that's about the entire firmware, the programming part. So the firmware is it is it has a ton of things to customize and a lot of things to digest as well. But it's definitely, it seems a bit um, out of seems a bit difficult, but it's rather, once you get used to it, it is pretty simple to understand, and you could start using it. So the other structures of 3D printers is, since we have I have given an idea about what electronics are and mechanics and software. So let's take a look into the extruder part. Normally in a FDM based 3D printer, the extruder is it is used to melt plastic and then deposit it layer by layer. Whereas in our countercrafting 3D printer, we can't use a similar extruder system. So rather, the extruder should be um, it should actually deposit concrete, a special type of concrete, right? So I would like to give you an example of how such extruders can be designed and built. So we were actually partnered with L&T some time ago, and we developed a extruder system for their countercrafting machine. So let me just quickly show you, what. So you could basically design your own extruder systems, get it 3D printed, and then you could, yeah. So you could start, so this is what this is the extruder system which we designed for L&T, and as you could see. So this one, it is used to rotate in different portions, and basically you also need to incorporate the mixing chamber on top of the mixing chamber, and choosing of different sensors and other stuff to measure the pressure and the flow rate of the different materials, and with that, so these things are all required to develop a extruder system. And so this is basically a bare minimum skeleton, but uh, that's where our this was our objective, and then we completed this and we handed it over to them. We 3D printed these parts and then we shipped it out to them. And in fact, they have been using this particular extruder mechanism in some of their prototypes. Even they are also into trying to build a countercrafting 3D printer. And yeah, so a quick summary. Let's take a look at different things which we discussed today. So we were I just gave you a very glimpse idea into what electronics are in a 3D printer, and the software, the firmware part. What is the responsibility of a firmware, and also we discussed about different mechanical parts. How to make mechanical motions. Different types of architectures which are available, like say core XY mechanism, delta type mechanism, uh, gantry type mechanism, and other stuffs. So uh, since we have a very limited time, I'm actually like I do understand we are going at a very fast rate. Uh, this entire to know to exactly to build a 3D printer, you need to have the skill sets in all these four areas. So you need to have skill sets in your electronics, mechanics, software, and do a lot of extensive research and development on the extruder as well. But hopefully, if you really have interest, probably you could definitely learn the different aspects a step at a time, and then you could really achieve it. And so let's have a discussion session now. And at the same time, what I'll do is we will also have I'll also post a reference video, which will be a very detailed reference video of steps or things to look out, or things to know for building your own 3D printer. All right. So thank you guys. And back to you, Dinesh sir. So let's take a look at our discussions now.
Uh, Thank you, Siddharth. I think today you have covered up that the maximum how to build a 3D printer. That's for
Yeah.
using for a contour craft.
And at the
I
same
think
time, I
mm,
do feel a bit odd, because the topics which we are looking right now is extensive topics, which due to the time constraint we are actually like uh, looking at it a very rapid pace. But things like these can be learned only with like say it requires a lot of time to learn these stuffs, right? So but it's definitely not impossible. It's definitely not that difficult as well. I could guarantee that to students. It takes a time. So I would also again recap to our students to if at all they are planning to build a 3D printer, it's right time for them to order a Arduino Mega 2560 microcontroller. Probably if at all because of lockdown, some companies are even delivering as well. So there are certain online platforms. If not, you could also students can try out Amazon for getting an Arduino controller as well. So with the Arduino controller, I think it's pretty easy for them to start working on the electronics. And once they start using these systems, it would be very easy for them to cope up and go into the core, much more complicated and complicated activators and other sensors as well. So getting an Arduino is a first step towards building their 3D printer. Yes, sir.
Siddharth, I think there will be a one question
Yeah.
uh, regarding a firmware. Whether we can directly transform the Cura G code to this Manlin firmware, or else we need to do it manually in firmware.
Okay, no, Cura is completely different. Okay, Cura is software which is used to generate your G code alone. Not uh, it is not used to say creating your basically Cura is used to control the uh, you know uh, generate the instruction sets for the microcontroller. For the firmware, you should be using Arduino. So Arduino is this particular software which I just we were discussing, right? So we'll be like loading the Marlin firmware over here, and from this if you could see on the TV screen, so this particular blue color part is actually the microcontroller. Once we connect the microcontroller with our computer, you have an option called upload over here. So once you choose, the entire sketch will be compiled, and the firmware gets uploaded over here. So for loading your firmware, you can't use Cura, you should be using Marlin. Yes, sir. Back to you.
I think that's it. Then I think no more questions are there.
Okay, okay, okay. So as I told you before, like I will try to leave a link of or it I'll, if not a video, I'll also reference certain subreddits from our Marlin array, if not say our RepRap community, which is to which students could actually get benefit of uh, checking it out. So and for every giant leap, you got to have certain small steps. So only with few small steps you will be able to create achievements. So the same that building a 3D printer is really not a rocket science. So definitely it's a good shot for them to try it out. Yes, sir.
And one more question we got it that from Mr. Shamir, that he is asking about totally how much cost or money that we need to spend to build a 3D printer.
I think around somewhere around like say 10 to 15,000. Say a very small, compact, basic 3D printer, or if not, uh, even in the order of say under 10,000 rupees, also you could scavenge certain CD-ROMs. Even there are lots of students have actually even the students with whom I have mentored have also created a 3D printer with a CD-ROM actually. So basically, you could get those CD-ROMs for dead cheap price. Say for a couple of hundreds of rupees, you could get a CD-ROM, right? So for every individual access control, you could use a CD-ROM's motor and other parts. So when you do it in that way, the cost of building a 3D printer would be around say 6 or 7K rupees. So it's not very expensive. It's pretty cheap actually. Yeah.
Yeah, and next question from Mr. Gokul Krishnan, that does this 3D printer is used in our cities for ready-made walls or compound walls, etc.
Okay. Uh, See, basically, countercrafting is still in research phase. All right. So till now, we don't have a commercially viable, commercial countercrafting 3D printer. But there is a company which is promising to deliver it in this year. But since it's in research phase, it totally depends upon the materials which you are planning to use. So we could hypothesize, like you could directly print reinforced, even the renderings which we saw in our introduction sessions of implanting the rebars, implanting the plumbing, electrical ducts, and everything. Every printer takes its own approach. So if you really want any special type of inserts, or any type of compound walls or anything like that, you could definitely do a build a machine based on the research. So I wouldn't give you a very precise answer on this. So the reason is because it's still in R&D phase. Yeah.
And there will be same like two questions are there. One is
Yeah.
about minimal wall thickness of a 3D printer model, and again same thing. Another one participant named Ganesh. He also asking this 3D printing model is there a minimum wall thickness or maximum wall thickness like that?
No, there isn't. See, for minimum wall thickness part, like say for machines like these, it depends upon the nozzle diameter. And normally the nozzle diameter is 0.4 mm in plastics extrusion based, FDM technology machines. But with 0.4 mm, if you try to print, the walls will be like really very flimsy and it will break off. So normally in our industry, in our 3D printing industry, people won't accept designs with less than 1 millimeter of wall thickness. But if you ask the same question for countercrafting, it totally depends upon the extruder size. So if the extruder width is say 50 mm, which is like 5 centimeter, this much size, so that is going to be a minimum wall thickness. You can't get less than that. Or if you really want to, print very thin walls, you got to change your extruder. So it depends upon your extruder type. And with regards to maximum wall thickness, there is no limitation. You could you could actually theoretically use your entire build volume to build a wall. Yeah, back to you, sir.
Yeah, see that. And next question is about a software tool. That is there any special course on 3D printer software tool or interpretation for understanding?
Uh, I don't think you need to take a special course and spend money on that. The reason is because you have enormous amount of resources available online, and with regards to 3D printing software, say I think you are asking about say the slicing software or what the majority of people will be using, right? So for converting their designs to G codes. For that purpose, you have a lot of resource available online. So all you need to do is just try out, install the software, try out G code thing, and you could also simulate in the same software and see, like say, based on your uh, based on your settings and based on your parameters which you have set. So you could check out how the results are, how the output will be. And apart from that, if you want to give suggestions on some courses, you could make use of uh, you know I'll also drop certain video links to slicing softwares and Cura. So even but I think that should do the job. So you need to practice, you need to try out and experiment out with different stuffs, so you will normally learn gradually. And instead of that, spending on additional workshops or anything, I think it's really not a good idea. But if you really wish to, then you could check out courses on say Coursera or Udemy, or platforms like those as well. Even they have paid courses over there. So if you want, you can check out them as well. Yeah, back to you, sir.
Dinesh Kumar sir?
Okay. I think I'll just grab some questions from our comment section right now. So Sultan and Ibrahim have asked a question like, are 3D printed goods okay, are 3D printed goods as those manufactured traditionally? Okay, I assume they are as good as things manufactured traditionally, right? So everything, Sultan, every manufacturing process has its own pros and cons. So let's say if you're manufacturing a injection molded part, so uh, when you compare it with the injection molded part, you could actually achieve, do the same build the same part using a 3D printer, but the cost of manufacturing using a 3D printer will be a bit higher, several times higher than the part which is manufactured using an injection mold. So where you'll get benefit is in printers like these. If you want to print manufacture certain custom parts, like say the parts which I showed you while parts like these which you design and develop by your own, and then if you want to manufacture them, so in that cases, using a 3D printer will be a very cheaper option, because you can't create an injection mold to create the parts like these, because injection molds are normally used for mass manufacturing. The cost of mold will run to several lakhs. So in areas like those, you will have a very high cost and benefit ratio using a 3D printer rather than using a traditional methods. So every technology has its own pros and cons. And Mr. Ganesh, any resolution was done in 3D printer. I think Ganesh, just try to be elaborative so that I'll be knowing what exactly you're asking. Anish Gupta, what do you think when 3D printers will be used by Indian construction companies? Yeah, so Indian construction field actually has enormous potential for using 3D printers. The reason is because the several companies, to my knowledge, are already into developing, into even Indian companies, like say I mentioned L&T before, and L&T is a company who does a lot of construction activities, uh, around the globe as well, and their main resource or main expenditure is actually manpower, right? So and as we discussed before, construction field is one thing which is not automated, which is almost only field, only which actually does in large magnitudes, but still majority of the work is manual. So um, in the Indian construction industry will, I'm expecting in around 10 years time frame, we could see a revolution in using counter crafting 3D printers in Indian construction industry. Yeah. So Sultan again, yeah. What are the differences between 3D printing and CNC milling? Okay, so CNC milling is again, if you want to see the similarities, there are only few similarities. The differences are drastic. Uh, Both work on G codes and M codes, but the differences are exact opposite. In CNC machines, you are basically removing, subtracting material to create a part, whereas in 3D printing, you are adding material to create a part. So that's the entire the core fundamentals actually completely changes over here. So that is a major difference. And apart from that, do we have any other questions? Okay, what resolution can a 3D printer print? Um, Depends upon the type of 3D printer. Uh, as the on yesterday's link, I have actually shared a HP multi-jet fusion technology in our Google Classroom. So if you could see that machine, they actually call it as a voxel. Voxel is a volumetric pixel. So basically, they are in the size of microns. So machines like those actually cost several crores, but when using those kind of machines, the resolution is like say way higher. It's almost in few micro. You could get a very precise control up to few microns. Whereas in machines like these, your resolution is actually limited to the amount of material being deposited, which is going to be a 0.4 mm over here. So just 400 microns. So that is the resolution. Okay, so Mandy, can multiple extruders be used in the same machine for larger output? Okay, so this is one interesting question. We can use multiple extruders, but unfortunately, we could only use one single extruder for printing one single part. Let's say in a single part, if you want to print multiple colors, you could use dual extruder, where one extruder will be loaded with one particular color, and say the other extruder will be loaded with other color or even other material as well. But that's not going to reduce the time. It's going to increase the time only. Uh, but rather, if you have a very enormous build platform, and if you have several extruders, printing multiple parts at the same time, so in that case, you are not going to reduce the time of printing of the time taken for printing is going to be same, but with the same time, you're going to print multiple parts. So in that way, it could help. So that's the only way where you could get an efficient increase in time factor while using multiple extruders. Other than that, there is going to be a decrease in time usage. Yeah. Okay. So do we have any other questions?
No, Siddharth, I think we completed mostly all the questions.
Okay. Perfect. Sure. So, if you have any other questions, you students, please do post in our Google Classroom, and also take a look in our Google Classroom as well. So we will be like continuously posting links from now on, and uh, so already I have even shared the links for the Arduino software download and the Marlin firmware to download. I mean the download link as well. So kindly have a check at it and. Probably even try to, so your assignment for today will be to check out reprap.org and to check out download Arduino and Marlin firmware and take a look into it. Yeah, back to you, Dinesh sir.
Yes, that I think if they have any other questions, we'll have it in Google Classroom then.
Sure, sir. Definitely. Yeah.
Yeah, okay.
All right then. So let's wind up today's session, and let's meet tomorrow at 4. And so tomorrow we'll be looking into what contour crafting has to offer for mankind. So tomorrow session is going to be about exclusively about the future prospects of contour crafting, wherein we'll be discussing how contour crafting is going to be used in extraterrestrial explorations. Because for all these days we have been discussing about, like, how it could give an impact in our globe, but countercrafting is one thing which is going to stay with us for, even for extraterrestrial explorations, like say exploring moon, like what NASA is having plans of using countercrafting 3D printers for creating moon bases and Mars base and all. And apart from that, we'll also take a look into, several applications of countercrafting, and we'll also have uh, discussion session tomorrow on building your own 3D printer. So for that purpose, I'll be sharing additional resources in our Google Classroom. So kindly, students who are not using your Gmail ID, kindly create a Gmail ID and then, sign up with our, just get registered in our Google Classroom forum, so that you get all our updates from our side. So thank you. Thanks a lot for today's session. Uh, and yeah, back to you, sir.
Yeah, Siddharth, thank you for today's session, and thank you for all the participants who take part in our session today. I think Madam is also there. Ma'am, ma'am, can you hear me, ma'am?
Okay, I think ma'am has.
Yes.
Okay, ma'am. Yeah.
Yeah, ma'am is there.
Yes.
Hello, ma'am.
Yes. Tell me, sir. What is about tomorrow's session, sir?
Ma'am, so tomorrow we'll be discussing about, the several applications of countercrafting 3D printers, and
Okay.
we'll be looking into different uh, interesting prospects, the future prospects of countercrafting, especially like say building extraterrestrial colonies, and
Okay.
what NASA is having plans of using countercrafting technologies in their
Oh,
space exploration. And
okay.
apart from that, specifically in country like India, what kind of impact it's going to have in the next, it's going to be a forecast for the next 10 years. And
Mm.
along with that, we'll also discuss about building our 3D printer part. So for that
Okay.
purpose, I'll be sharing certain resources today in our Google Classroom,
Okay.
which I suggest our students to take a look at it, so that they will get a, the topics which we are covering is actually huge topics which require
Yes.
separate individual works. I do understand that, but unfortunately, because of, the time constraint part, we are only able to see the tip of the iceberg and not the part beneath it.
True.
So
True.
uh, but at the same time, I would really emphasis on one point, that
Mm.
building a 3D printer is really not a rocket science, or not a complicated thing.
Mm.
It is, all we need to do is, like, take few steps at a time. Begin with, I have suggested our students to, begin with Arduino platform, try out certain examples in that, and if possible during this lockdown also, if possible, if they are able to get a hold on an Arduino motherboard, which is going to cost less than say 800 rupees or something online.
Mm.
It is really not that expensive, so students could try out. And it's not only going to benefit students for building their 3D printer, it could also benefit them, like say if they want to build a robo, or say any robotic device, or even building a drone, or say whatnot. They could control what different activators and other get data from sensors and build their own stuffs. So it's a very interesting platform, and so it's a very, people could really, I do wish, students will try out this particular platform. So it's so that they can take use of it, in
Okay.
the near future. Yeah.
We can also ask suggestions. What is the requirements of the audience also?
Sure.
If they require any particular thing also, we can cover in the next. This is the 4th day, is it not? Today
Yes.
is the 4th day.
Yes.
So another 2 days we have. If they need any
Yes.
particular requirement also, they can post it in the Google Classroom. So
Definitely.
that we will come and answer that also.
Yes, ma'am.
Okay,
That's
okay.
definitely. Ma'am.
That
Sure.
also we can cover to some extent. This triggering of this initiative should end up with a project. We will see how many are
Definitely.
turning up
I
for
do
the
wish.
3D project, 3D printer project. Okay.
Sure.
Thank you very much. It's a very nice
Thank you,
session.
ma'am.
Okay, thank you.
Thanks.
Dinesh Kumar sir.
Thank you, ma'am.
Yeah, you can also post in the Google Classroom.
Yes, ma'am.
Any feedback or requirements from the participant side also, we will try to cover that also in the next.
Sure, ma'am.
Okay, sir. Thank you.
Thank you, ma'am.
Siddhartha.
All right. Thank you, ma'am. Thank you, sir. Thank you, students. Bye.
Yeah, thank you, Siddharth. Thank you all the participants, and kindly fill up the feedback form for today's session.
All right.